1 says to convert to degrees. Remember, this is over 60, so it's going to be 16 plus 49 over 60 is going to be 16.817 degrees. Number 2 says to convert 1.75 degrees to DMS. So it's going to be 1 degree, and then that 0.75, so 0.75 times 60 is going to equal 45. And then I have 0 seconds. So altogether, I'm going to get 1 degree, 45 minutes, and 0 seconds. Number 3 says to convert pi over 6 radians to degrees. So it's going to be pi over 6 times 180 over pi. So I'm going to get 30 degrees. And then for part B, convert negative 225 degrees to radian measure in terms of pi. So we're going to say negative 225 degrees times pi over 180 degrees. You're going to keep the pi notation. So I'm going to get negative 5 over 4 pi. For number 4, radians to degrees, 5 pi over 7 times 180 degrees over pi. So when you multiply fractions, you multiply going across. I'm going to get 900 degrees over 7. And it says to the nearest 100, so that's 2 decimal places. So this is going to be 128.57 degrees. Convert 169 to radian. So I'm going to get 169 degrees times pi over 180 degrees equals, let's see, 169 times pi over 180, 2.95 radians. We're looking for the coterminal angle. Remember, you're just adding and subtracting 360. So your angles have to be between 0 and 360 for the first one. So we're going to say 760 minus 360, and I get 400. So I have to do it again. 400 minus 360 equals 40. And then this one says 47 pi over 12. So remember, it has to be between 0 and 2 pi. So you're subtracting 2 pi. 47 pi over 12. I'm going to subtract 2 pi. So think of it like this. It's 47 over 12 minus 2. So then you're going to try and get a fraction. And that's 23 over 12. So that's going to be 23 pi over 12. And this is between 0 and 2 pi. Now, for number 6, slice of pizza has the shape of a sector of a circle where central angle is 46. Some measurements of the pizza are shown below. Find the area of the crust, round your answer to the do not round any intermediate computations, round your answer to nearest tenth. Okay, so all we need to do here is talk about the sector. And our formula here, we need to convert theta or 46 to radians. So 46 degrees times pi over 180 is going to be 23 pi over 90. And then we're going to use the area of the sector, but we're going to subtract the area of the large part of the sector minus a small part of the sector. So it's going to be all of this minus this part. And the way that we write that out is with the sector formula. Again, area of the large minus the area of the small. So all I'm going to do is put this in parentheses in my calculator. So just the way we see it. And remember that this is multiplication between the half and the perfect square. And then as you're putting it in, again, you want to make sure that you're using the correct notation and using pi as well. You can also use the calculator that's given to you in the problem. That works as well. I do recommend, though, a device while you're taking the test. So it says to round to the nearest tenth. Our answer here is going to be 22.5. 7, you're going to have 3 parts. It's just asking you if, like, to find the equivalent. So for part A, it's asking you, is tangent odd, even, or neither? Tangent is an odd function. We also know that sine is an odd function. And then it's asking you which one of these is the equivalent. Whenever you have a negative inside the degree, you can also take it out. Now to check this, it would be the first one here. So to check this, you can just type this into the calculator. The first thing you want to do is make sure you have the correct mode, whether it's degree or radian. So right now we're doing with degree. And so that's going to be tan of negative 175. And I get that decimal. And if you want to check our solution, you're going to press negative tangent 175. And if you get the same solution, then that's your equivalent answer. Now for sine, this is in radian. We're going to change the mode back to radian. And it should be the same thing where you just take it out. This should be the solution. So to test this, it's sine negative 4 pi over 5. I get that answer, and then we test this. And we get the same solution. So That's number 7. Now for number 8, you're just using the formula given to you. The numbers in. So velocity is 80. You're going to square that. Your theta is 4 pi over 9. And then your g is going to be 9.8. So putting that all together, I get 80 squared times sine 2 4 pi over 9. That's multiplied. And then all of that is divided by 9.8. I'm going to work the numerator first. I do want to make sure that this is all in radian. So when you check your mode, you want to make sure it's highlighted in radian. We're just going to enter it the way we see it. 80 squared times sine 2 times 4 pi over 9. And then all of that divided by 9.8. It wants 2 decimal places, so that's going to be 223.36 meters. That's our solution. Number 9 says to use the calculator to evaluate. You just enter these into the calculator, but you want to make sure, again, you're in degree mode. So tangent of 84, 9.51, cosine of 44, 0.72, sine of 17, 0.29. For number 10, we want to recall that secant is 1 over cosine. So 1 over cosine theta is equivalent to secant. And then 1 over sine theta is equivalent to cosecant. And 1 over tangent of theta is equivalent to cotangent theta. So we're just going to make sure we have the correct tenths. Remember, this first one is degree, and these other 2 are radians. So we're going to have to change that in our calculator. So here we want to check the mode. We have degree. So I'm going to enter 1 divided by cosine, and then negative 330. I'm going to get 1.15 because it's 2 decimal places. 1.15. And then we change that to radian for the next 2. So that's going to be 1 over sine 10 pi over 9. And that's going to be negative 2.92. And then cotangent is going to be 1 over tangent, and it's pi, which is the same thing as 90. And that's going to be undefined. Okay, so for number 11, a ladder leans against the side of a house. Angle of elevation is 68 degrees, where the bottom of the ladder is 16 feet from the house. Find the length of the ladder. So all you need to do here, again, we need to check the mode. We need to be in degree. is you got to decide which trig identity you're going to use. I'm going to use the secant. And let's talk about why we're using secant. When we label this, this is our theta. So that means that this is the adjacent. This is the hypotenuse. And this is the opposite. So when I look at secant, I have the adjacent and I'm trying to find the hypotenuse. So the hypotenuse, or the unknown side, was going to be x. So this is going to be secant theta equals hypotenuse over adjacent. So secant of 68 equals x over 16. And then we cross multiply. So 16 times secant 68 degrees equals x. 16. And instead of saying secant, we're going to say in our calculator 1 over cosine. And then it's going to be 68. Enter. We're going to get x equals 42.7. And that's the length of x, or the hypotenuse. 12, it says use the cofunction of the equivalent of sine of 62 degrees. So we're going to go ahead and use the first one right here. So that's going to be sine of 62 degrees is equivalent to cosine of 90 degrees minus 62. So equals cosine of 28. And then when you put that into the calculator, oh, we want to make sure we're in degree. That's going to be 0.8829. The average monthly temperature changes from month to month. Suppose that for a given city, we can model with the average temperature of a month with the following function. Okay, so this function has for transformations. Let's see. The equation f of t is the average temperature in a month of degrees Fahrenheit. And t is the month of the year, January, February. Find the following and necessary round to the nearest hundredth. Okay, so the frequency, the first thing you need to know is the constants. Let's use a different color. A, B, and D. A is going to be what's in front of the sign. So that's going to be negative 30. And then you have B is going to be your constant in front of the T. And then D is going to be the 61. Now to find the frequency, okay, so the frequency is the reciprocal of the period, but in this case, we're going to say it's b divided by 2 pi. So to find the frequency, it's going to be pi over 6 divided by 2 pi. Pi over 6 times 1 over 2 pi. So then we get 1 over 12. So the frequency is 1/12. Then the next thing it's asking for is the maximum average number or average temperature in a month. So to find the maximum, the max is going to be the D plus the absolute value of A. So we're getting 61 plus the absolute value of negative 30. 61 plus 30. The max is 91 degrees. And then next, we're going to determine the period. Oh, that one's easy. So all you need to know is that the period is the reciprocal of the frequency. And the frequency was 1 over 12. So that means our period is 12. I'm going to show you how to graph something without a calculator, and then we're just going to check our work with the calculator. So this is our function. First thing we need to know are our constants. A equals 2, B equals 1. It's a 1 here because there's no coefficient in front of the x. So we assume it's a 1. And then D as in David equals 3 over 2. Remember, this is your vertical shift. I am going to start using decimals just to kind of get through things kind of quickly. So we're going to use parent function. Parent function is going to be sine theta or sine x. And then we're going to determine the amplitude. The amplitude is just going to be your A, which is equal to 2. So that's our stretch. Our max is going to be D plus absolute value of A. And that's 3 over 2 plus 2. So that's going to be 3.5. Our min is going to be D minus the absolute value of A. So that's 3 over 2 minus 2 equals negative 0.5. And then we need to determine the period. The period is going to be 2 pi over B, which is just 2 pi because B is 1. So when we divide our period, that means it's going. We're making the table based on the period. So we have an x and a y. We know that our sine function starts at the origin. So because of the vertical shift up 1/2, so we know it's going to be 0, 3 over 2. And then at pi, over 2 is when we get our high of 3.5. And then at pi, we're still at the midline, which is 3 over 2, or 1 over 5. 1.5, excuse me. And then we have 3 pi over 2. That's going to take us to our low point of negative 0.5. And then 2 pi is going to give us back to our midline, 1.5. And I say midline because that's the line that we use in our vertical shift. So it's almost like our x-axis has gone through kind of like red in here. So let's go ahead and graph our function. We have 0, 1.5. And then we have pi over 2, 3.5. Right here. And then pi is at 1.5. 3 pi over 2 is at negative 0.5. And then pi over 2 is at 1.5. So when we graph this, we're going to go like that. It's a curve. Again, this is just a sketch. And it's going to continue on. Look at number 16. It says to match the graph, and these are a multiple choice. It's going to be this one right here. Y equals negative 1 plus cosecant x. And then you can also just use Desmos. That's what I would do. 16, there's 3 graphs you have to match. In 16 and 17, I would also recommend just using Desmos. So I just type in the answer as I knew it, and then we can just examine it by looking at the labels on the graph. So if we look at this right here, like right in here, this is going to be 3 pi over 4 comma negative 1. Right, because this is the x and this is the y. This is negative 1, and this right here is 3 pi over 4. And if we continue to the right, this is broken down into fourths. So over here, we are going to have right there 7 pi over 4 comma 1. And again, we can just check this. So these are like multiple choice. Once you've used one, you're not going to use it again. You could just type them into Desmos just to confirm. If not, you're going to have to go through all the process of finding the max, the min, the midline, the amplitude, and the period. Or just, type it into Desmos and see what happens. So 3 pi over 4 comma negative 1. We kind of already knew that one. And then 7 pi over 4 comma 1. So this one right here matches our solution of what's pictured. So this is all calculator. I like to just keep everything in degree and then convert back to radians in this case. So we're going to press second, tan, and then it's square root of 3 over 3. We're going to get 30 degrees, but it wants it in radian. So 30 degrees is equivalent to, so my answer is 30 degrees, but that's equivalent to pi over 6. And then down here, again, I want to keep everything in degrees. You're going to enter tan negative 1 of tan 5 pi over 3 is 300 degrees. So second inverse tan 300. Enter. That's going to give me negative 60. So in that case, negative 60 degrees is going to be equivalent to negative pi over 3. All right, because it's divided by 180. So that's negative pi over 3. I wanted this to be easy. So this says we're going to do everything in radian. So make sure we're in radian mode. This is going to be 1.33, or excuse me, second sine 1.33. And that is undefined. So when it says not real answer, that's going to be undefined. And then second 10, 0.59. So this is 0.53. And then second cosine, negative 0.68 is going to be 2.32.